Hi everyone, welcome back. This is the 13th video in the series of algorithm animations, and if you have not watched my playlist till now, please check the playlist in the description or by the I button in the top right corner. Let's start. I am Shreyaans Jain. Let's first discuss the problem statement. We have an array of size n. We are also given an integer k, and we need to return the count of distinct numbers in all window subarray of size k. What does that mean? It means that for every window of size k, we need to return the distinct elements in it. If you don't know what is a subarray, I have told this in my previous video. You can check that video by clicking in the top right corner. Let's see the algorithm. We will make a window of size k, and then we will use the hash map to check if it is unique or not. How? We will see it in a moment. And then we will slide the window. So what are the steps? We will make the window of size k, use the hash map to check if it is unique or not, and then we will slide the window. It is similar to what we have done in the previous video. Let's see the animation with an example. We need to return the count of distinct numbers in a window of size 4, and this is our array. So how we will do it? We will make a variable window size which will keep track of the size of the window, another variable distinct elements which will keep track of number of distinct elements we have in the window, and a hash map which will store the elements with their frequency. How we will use it, we will see in some time. So firstly, we take the first element in our array. So what will be the window size? Initially it is 0, and we take this one element, so size will increment to 1. Now see if this element is already present in this map. What does that mean? It means that we already have this element. And if we already have this element, then this element is not unique. But if it is not in the hash map, so it means that we are getting this element for the first time. So this is a unique element. Okay, so we will check one is there in map or no. So one is not in map, so we will put 1 at here with the frequency 1, and we'll increment the distinct elements. And we need to make a window of size 4, so we will take another element which is 2. Now the window size will be 2. Again we will check if 2 is present in hash map or not. Since 2 is not present in hash map, we are getting it for the first time. It's a unique element. We will put 2 at here with the frequency 1, and we will also increment distinct elements. Window size is 2, which is less than 4. We need more elements. Take this one. Now taking this one, our window size will increment to 3. Since this one is already present in our hash map, so this is not a unique element. So we will not increment distinct elements, but we will increment the frequency because we got a 1. Window size is 3, less than 4. We need one more element. We will take this 3. Taking this 3 will make our window size equals to 4 because we have 4 elements now. Is this 3 present in our hash map? No, so it's a distinct element. We will put it in the hash map and also increment our distinct element. We have done the first step of our algorithm. We have made the window. Now we need to slide the window, which is our second step. How we will slide? We will take this element in our window and we will remove this element. So this way we are sliding our window by taking the next element and removing the last element. So we will take this 4. Is 4 present in our hash map? No, so it's a distinct element. We will put it in the map and also increment the distinct elements, and we need to remove this one, so we will remove it. Now see, we have removed the 1. So we will decrement the frequency in our hash map because we have removed the one, and hash map tells what are the elements present in our window. See, the frequency of 1 now is 1, which means that we have 1 in our window, so there is no thing to worry. And now we will again slide the window. We will take this element and remove this element. So if we take this element, frequency will increase, and if we remove this element, frequency of this will reduce. In all this sliding window process, we are taking one element and reducing one element, so our window size remain constant. And here we have removed 2 and frequency reduced to 1. Since the frequency is 1, what does it means? It means we have 1 2 in our window, so there is nothing to worry. But now comes an interesting case. We will again slide and we will take this 3 and increment its frequency. We will remove this element, that is 1, and if we remove it, we will also decrement the frequency of this in the hash map. Its frequency is 0. What does that mean? It means we have lost one element from our distinct elements. We have lost one element from our distinct elements. If the frequency was greater than equals to 1, that means we have that element. But if it is 0 now, that means we have lost one element. We need to reduce our distinct elements. So this was sliding window problem. Let's see the pseudocode. We have this count distinct, which will print the distinct elements in the window of size k. This is the variable which we take. Distinct elements equals to 0 in starting, and hashmap map which we taken, and we will make the window of size k. What does this line means? This line means if the frequency of the element in the map is 0, that is we are getting the element for the first time in our window, we will increment distinct elements, and we will increment the frequency of that element in our map. This is the way we made the window, and we will return the distinct elements which we have in our window. Now we will slide the window. This is the loop to slide the window. We will take the next element of the window, that is ARRI, and if its frequency is 0, we are getting that for the first time. We will increment our distinct elements like we did here, and we will also increase its frequency, and we need to remove the last element, so that is ARRI minus k. And since we are removing it, we will reduce its frequency minus minus. And if we are reducing the frequency, and after reducing the frequency becomes 0, that is frequency of ARR I minus k is equals to 0. That means we have lost the element, and if we have lost the element, we need to reduce the distinct element minus minus, and after that we will print the distinct elements we have. This is the for loop. Let me tell you again this code in brief. We have this function which prints the distinct element in a window of size k. We take distinct elements and a hash map. We made the window. If the frequency is 0, that is we are getting it for the first time. We increment the distinct element and also increment its frequency in our map. We print it. Then we will slide the window. We take the next element, and if the next element frequency is 0, we increment distinct elements. We also increment its frequency. We need to remove the last element, so we reduce its frequency, and if its frequency becomes 0, that means we have lost an element, so we will distinct element minus minus, and then we will print the distinct elements. Thanks for watching. Don't forget to hit like and subscribe to view more content like this. And if you have not still subscribed this channel, please subscribe. I am planning to make more videos in the future, and by animation it will help you a lot.